Hello there once again. In this lesson we'll learn about circles. So it's a subsection on coordinate geometry. Coordinate geometry from Core 2 if you're following the Edexcel syllabus. So it's chapter 4 on the Core 2 book. So there's a bit on circles there. Alright. So before you learn the circle equations and everything else, you need to learn couple of you need to be very thorough of a couple of things that you've already learned from Core 1. Those two things are the length of a line. To work out the length of a line, if you're given two coordinates, okay, and the other thing that you ought to be very thorough with is to work out the midpoint of 2 points if you're given the coordinates of those 2 points. Alright, so let me just quickly run over those two. If I said that point had coordinates 4, 10, and this point had coordinates 1, 6, alright, then you need to work out the length of this line. So the equation for that is r squared. R is this length, so I just say r squared is equal to the difference in the x coordinates, so x2 minus x1, and that squared plus the difference in the y coordinate. It really doesn't matter in which order you subtract the y coordinates and the x coordinates, because that minus answer will get squared and it will become a positive. So the difference between the x coordinates is 4 minus 1, that whole thing squared, and the difference in the y coordinates is 10 minus 6, and that whole thing squared, and 4 minus 1 is 3, 3 squared is 9, 10 minus 6 is 4, 4 squared is 16, so that is that, and 9 plus 6 is 25, so 25 square root of 25 is equal to r squared, so therefore r is equal to 5. Okay, so you need to be very thorough with this to work out the length of a line. The other rule that you ought to be very thorough with is to work out the midpoint between two lines. So I'll again use the same coordinates. So that's 1, 6 and 4, 10. To work out the midpoint, you do y1 plus y2 divided by 2 and x1 plus x2 divided by 2. So the sum of two y coordinates is 10 plus 6 divided by 2. X coordinate is 1, 4 divided by 2. So that is equal to 8, and that is equal to 2.5. So if I put it in the correct order, x first and then y, it's 2.5, 8. So that's where the midpoint is between those 2 points. Alright? Okay, now let's move on to circles then. Right, so let me draw an xy axis, and I'll just choose a point here, and I'll call that 3, 4. Alright, and this coordinate, another point here, is on the origin, 0, 0. So if I were to work out the distance of this line here, alright, so I'm just showing you how the circle equation is derived. Okay, it's not too difficult to understand, but if you realize how the circle equation is derived, it'll really help you solve lots of questions on the circles, instead of me just showing you what the circle equation is. So alright, let's get back to this. So this point here is the origin, this point here is 3, 4, and if you work out the length of this line, which is the difference in x, which is 0, 4 minus 0 squared, plus the difference in y, which is 3 minus 0, that is 3, so that's and then that squared is 9, and this squared is 16. Alright, that gives you a value of 25 if you add those two results. Okay, so 3 squared plus 4 squared is equal to 9 plus 16, which is equal to 25, so therefore r is equal to 5. So this length here is 5 units. Alright, let me choose another point here, and I'll call that minus 3, 4. And here as well, the difference in the x-coordinate is 3, the difference in the y-coordinate is 4. This negative sign doesn't really affect it, because even that negative answer, if you square it, you'll still get a positive answer. So that's still 9 plus 16, 25, and that length from the origin to that point there is also 5. Okay, and I'm going to take another point here. This point here is going to be minus 3 comma minus 4. Here again, the length from this point to the origin is going to be 5. Again, if you work out the difference in x and the difference in y, and you square them and then you add them together, it will be 25. Square root of 25 is 5. You probably would have figured out what I'm going to do next. So this point here is going to be 3 comma minus 4, and here again the length is 5. Alright, so let me just do this. Let me just hold your attention for a few moments and watch what I do. Okay, there we go, down there and back to where I started. Alright, now that looks like a circle. Alright, so what I want you to see is that on the circle's circumference, on the circle's perimeter or circumference, there are points, there are coordinates where if you drew a line to the center where the origin is to the circumference, it will have a length of 5. Well, you learned that from primary school, where if you draw a line from the center of the circle to the perimeter, it will be the same wherever you draw it on the perimeter. That's basically the radius. So the radius of this circle is in fact 5. Alright, but there are coordinates here, here, here. The only problem is you wouldn't get nice rounded numbers like this. So you'd get awkward values, you know. You get 2.3 something like that there, and 4.2, just so that the squares of both of them add up to make 25, and then thereby the square root of that result gives you 5. Alright, so because it's all around the circle, if you drew a line from the circumference to the center of the circle, it's going to be 5. The equation of the circle is this. Alright, so before I derive the equation of the circle, let me start off with the length of the line, which is r squared is equal to x2 minus x1 squared y2 minus y1 squared. Alright, so my x here was 3 and my x1 was 0. So x2 was 3, x1 was 0. And my y2 was 4, my y1 was 0. Alright, and therefore that is equal to 5 squared. But if I had to write a general equation where this coordinate could be anywhere here, alright, so if I want to draw a circle from the center of the from the origin to this point, draw a circle around like this. If I say that was 5 comma 6, I would have to say 5 minus 0. Alright, but if I said that was just the unknown x value, I would say that's x minus 0 squared plus y minus 0 squared, my arbitrary y value. Alright, and the radius could be anything that I want it to be. I could say I want a radius of 7, so therefore radius squared is 49. Alright, so if I solve this, x minus 0 is still x. It's x squared plus y squared is equal to 49. So that's the equation of a circle. Alright, that's an equation of a circle drawn from the origin, which has a radius of 7 units. Alright, So this thing here is not exactly the radius, it's the radius squared. Alright, so that radius there is 7. Okay. Let's look at another circle equation. I'll say this is equal to 100 is equal to x squared plus y squared. So in this equation, what's the radius? The radius is of course 10, square root of 100. Alright. And let's say you want to figure out this point here. So at this point, you know the y coordinate is in fact 0. Alright. At this point the y coordinate is 0. So if I say 100 is equal to x squared plus y is equal to 0 squared, that is just 0. So x is in fact equal to plus or minus 0. So when y is equal to 0, the x coordinate is plus 10 or negative 10. That's why you got a plus or minus, to show you that as another point on the graph, on the circle, where when the y coordinate is 0, x is 10 or x is positive 11. So there are 2 points. Alright. So if I want to figure out what the y coordinate would be, if I said this had an x coordinate of 8, so what's my y there? So again I write the circle equation, and x is 8, so I'm trying to figure out what y is. So 100 minus 64, which is 8 squared, and y squared is therefore equal to 36. So therefore y is equal to plus or minus 6, because when x is 8, there are 2 points on the graph. One is positive 6 and the other is negative 6. Alright, so that's how you manipulate the circle equations. Alright, so what would you do if you had to derive an equation of a circle which didn't have its center at the origin? Alright, so let's say you had to derive a circle equation that had its center somewhere here. Alright, this is all what you got to do. If you figured out the center was somewhere here, and I'll call that coordinate 2, 3, all you do is, if the center's shifted to the right, what you got to do is you got to take that away from the x. Alright, so it's x minus 2 whole thing squared, and if the center has moved upwards, again you got to take that away from the y, because the upwards and downward movements are to do with the y coordinate, plus y minus 3 squared. And depending on the radius, so if this radius was 5, it would be equal to 25. Okay, so when you move to the right, it's taken away, so it's negative. Move up again, it's taken away, it's negative. Alright, so let's look at an example where the center is moved below and to the left. So this circle here has coordinates minus 3, minus 4. Alright, so if it's moved to the left, what you've got to do is you got to add it to the x and square it, and if it's moved down, you've got to add it to the y and square it. Alright, and again, if this radius was 5, it's 25. Alright, so it's moved to the left, so therefore you've got to add, so you should move down, so therefore you've got to add again to the y coordinate. Alright, whereas if it's at the center, if the center is at the origin, all you got to do is just work out the radius and square it, and just say x squared plus y squared, square the radius. If the center has moved left or right, top or bottom, you got to do these. If it's moved to the right, it's negative. Moved up, it's negative. Left is positive. Downward is positive. Alright. I hope that was helpful. I'll probably put another video dealing with some more complicated theorems to do with the circle. I hope this was helpful so far. Thank you, and I'll see you soon. Bye bye.